With these last three types of angles, they all have something in common. So see if you can figure out what a secant, secant, tangent, tangent, and secant, tangent angle all have in common. The location of their vertex. If I highlight where their vertex is located in each of the three angles, notice their vertex is located outside of the circle. So this is our last possibility. We've discussed if the vertex is on the center point. We've discussed if it's on the circle, if it's inside of the circle, and now the last possibility is the vertex is outside of the circle. So if the vertex is outside of the circle, then the measure of the angle is equal to 1/2 the measure of the bigger arc it contains minus the smaller arc that it contains. And what do I mean by bigger arc minus the smaller arc? The bigger arc in a secant-secant angle would be this arc that's contained in between the angle. The smaller arc would be this one. So it's the two arcs that are between the sides of that angle. So for example, if I knew and I want to find the measure of my secant-secant angle, I would do 1/2 the big arc, which is 120, minus the small arc, which is 30, or half of 90. So the measure of my secant-secant angle in this example would be 45 degrees. For the tangent, tangent, and secant tangent, you're going to calculate the angle measure the same way. Except I'm just going to highlight for the tangent, tangent angle, the bigger arc is the major arc of that circle. Smaller arc is the minor arc. So notice that in a tangent-tangent angle, the big arc and the small arc make up the entire circle. So really all you need is one arc to calculate the measure of this angle. So let's say that I gave you that the major arc was 310 degrees, and then I asked you to find the measure of that tangent-tangent angle. We could then find the measure of the minor arc by subtracting 310 from 360, since we know that's going to make a full circle. So the minor arc would then have to be 50, and we would do the same process as before, 1/2 the big arc minus the small arc, or 1/2 260 degrees, which would be 130 degrees. So that would be the measure of my tangent-tangent angle. For the secant-tangent angle, large arc would be what I'm highlighting here in blue, and then the smaller arc would be the arc I'm going to highlight in red. Notice that the arcs have to be between the sides of the angle. So here's my example. Let's say I call this X, and let's say I give you that this smaller arc is 30 degrees, but then I'm going to also give you the arc that's outside. I'm going to call this, and then I'm going to ask you to find the measure of angle X. Well, we know that since the vertex is outside of the circle, I'm going to do 1/2 the bigger arc, which I don't know, minus the smaller arc, which is 30. And how can I find the bigger arc? Well, I know that those three arcs have to add up to 360. So if I do 360 minus 215 plus 30 is 245 degrees. So when I subtract those, I get 115 degrees as the measure of this big arc. So now I have to do 1/2 of, and 115 minus 30, 85, or 42.5 degrees as the measure of my secant tangent angle. So again, the key to doing these problems is looking for the location of the vertex. There are 4 possibilities. So those were some pretty straightforward examples that I went through with you, but now here are some examples where you may have to work backwards. So for all of those, I gave you some arc measures, and you had to find the angle measure. But now what if I give you the angle measure, and I ask you to find the measure of an arc? Again, look for the location of the vertex. This is an inscribed angle. Its vertex is on the circle, so we know that the angle is equal to half of the arc. Then I know in order to find the arc, I would need to double that angle, because normally the half of the arc is equal to the angle. So to get rid of that 1/2, I'm going to multiply by the reciprocal. So I would get that arc has to be 90 degrees. For this next example, let's say I give you this angle is 15 degrees, and this arc is 120 degrees, and I want you to find the measure of the minor arc. To do this, since the vertex is located outside of the circle, I know that to find the measure of the angle, I have to do, so the angle would be equal to 1/2 the big arc minus the smaller arc. So we're just going to set up an equation but put a variable in for what we're trying to find. To get rid of the 1/2, again, we're going to multiply this side by 2, and then if we multiply this side by 2, that would cancel out the 1/2. So we get 30 equals 120 degrees minus x. If I subtract 120 from both sides, I get negative 90 degrees is equal to negative x. Divide by -1 to get x is equal to 90 degrees. If you ever get a negative angle measure, that's how you know you probably made a mistake somewhere along the way. This next one is a chord angle. So let's say that I give you this angle is 160 degrees, and I want you to find this arc. So if I look at the location of the vertex here, the vertex is inside of the circle but not on the center point. I know that the measure of the angle is going to be equal to 1/2 the sum of the diagonal arcs, so that would be 200 plus x. If I multiply both sides by 2, this would cancel out, and then I get 320 degrees is equal to 200 plus x. And then all I have to do is subtract 200 to get x is equal to 120 degrees. So hopefully this kind of gives you a better idea of some different examples that you're going to see and how to set up the equations. Again, the key is to remember, look for where the vertex is located. All you really need to do is memorize those 4 different possibilities and how to calculate the measure of the angle and the arc based upon where the vertex is located. So just remember those 4 different locations for the vertex.